Hi, thanks for the talk. It was very exciting, interesting. Quick question. What percent, it seems to me you've spent some time looking at statistics about science and scientists. What percent of the greatest, let's say, top 100 scientific discoveries were made as a pure accident, you think? While people are looking for something completely unrelated?
Great question. So it depends on the field a little bit, and it depends on time. So 50 years ago, by and large, most physicists had no idea what they were doing was going to be useful. But chemists did. They knew a lot more about it. So I think something like 80%, because the chemicals industry started in the 1870s. So already there was an idea that you had an industry to translate to. More recently, then, physicists have had a better idea. So there's something about perceived utility, and then there's something about real utility. The interesting thing is now it goes the other way. Now sometimes people think it's going to be so useful, it's going to be great, and actually lost without trace. Or it got subsumed, more often it gets subsumed into general science practice and goes on. So that's what I can say for the moment. There's more statistics in the book. I tried to analyze exactly that.
Thank you. Next question from the bottom row in this section.
Thank you very much. I was struck by your comment about science research becoming much more competitive, because if you assume that we know much less, or there's much more to be discovered than we know already, I suppose I don't understand. Why? Well, I suppose you're suggesting that we're focusing on researching things that we know that we don't know, rather than things that we don't know that we don't know. Yeah, and therefore I then say, well, what can be done to encourage us to explore the things that we don't know more?
Yeah, it's a very good question. But we have to be a bit careful, because science, I think, was always competitive. If you look at Newton, Leibniz, they were vastly, they hated each other. And they were trying to get there first. So 100% of people in that field were fiercely competitive, because there's only 2 of them who could do it. I think the problem is this: because you increase, it's like the attention economy. Because the visibility of individuals goes up, people cluster around those themes. So this idea of memes, and so this is the idea about bandwagon science, and it's effective also for communities to do that, because they can leverage funding out of doing it. So you have to fight against those sort of pressures, and you have to, because there's enormous amounts of science. I mean, there's so much we don't know. Like I look in nanoscience, I'm certain I'm going to be doing that till I die, because we're so bad at it. But we know it can be done because the body does it. So I think so you have to make sure that people coming into science don't just go into the bandwagons, but go into a wider area. And that's something about mentoring and changing the idea of the community about what is success. So it comes back to this idea that citations is the important thing. You get cited more if you're in a bandwagon field, because otherwise you're in a backwater. But of course, you're more likely to do something profound in the backwater. So we have to encourage people to be working in these other areas. So maybe a metric, which is the distance to other people, would be something that would be interesting. How far you are away from everybody else.
Sorry, can we give the mic back? We're just recording.
Also, funding surely has got to be a big influence on this. So it's somehow to influence the sources of funding so that they don't jump on the bandwagon too.
But they're competitive as well. So if I'm sitting in a particular agency, I want to have got really good things out of this, and everybody else is doing 2D materials, and so I better do it as well. So there's a huge pressure on those people. So you have to find some nice way to help them feel good about funding wider things as well. So that's about timelines, probably. So it's impact not in 5 years, but in 50 years. And normally they can't afford to do that because their career is not based on that. So lots of very interesting questions about how you intervene.
Thank you. Just to let the gallery know, we will be coming up to you after we've done down here. So don't worry if you have a question. There is a gentleman here. Thank you.
Thanks a lot. I enjoyed the talk a lot. What's your take on the issue about your Bitcoin example? What's your take on the issue of scientific reproducibility and the bias or perceived bias that those high-end journals have to only publish the research that gave positive results and not focus on the quote-unquote failed experiments?
So there's a big discussion in the community, and there are statistics like, so some companies, for instance, in the pharma business, they tried to replicate 100 of the top papers, the synthesis or the results, and I think they found like 20% of them only worked, or they could get them to work. So a bit more than that. Which seems actually already quite reasonable for me, but if you read it from outside, that sounds terrible. In the sort of field that I'm in, the heart of physical sciences, I would say, I don't think there's a problem about reproducibility. I think generally, because there's so much supporting data that needs to be there, that it's very difficult to have something that's completely flaky. There are some things that get published, but as I said, they just fall off the tree. So there's stuff in the literature, and the first-year students believe it, and by the time they're a third-year student, they go, yeah, no, that's flaky. So you sort of get some sense about how to read it. I think there are other areas, the biological sciences particularly, where certain parts of it are very difficult. And it's because those systems can't be controlled as well. They're just very complicated systems. I don't have a strong view at the moment about whether you have to change the science paradigm for that or not. I think it is progressing reasonably because it still generates new results. There is still new understanding that emerges very impressively. So if that is still going on, I don't see a need to change it. This problem about negative results, I mean, everybody knows there's lots of null results. If we published all of them, then we would be 100 times the number of papers. So actually, there is something very important about not publishing things that don't work, in my view, because it's about stories. If we publish the stories that actually, it's like you read the story and then halfway it went into gibbledy-goof and it just stopped. That would be a bit of a problem in our libraries. So turning science into stories is the right way to communicate them. Sometimes you want to be able to tell people that something didn't work, so we could imagine a different way of doing that, but I don't think the right thing is to actually have publications for that.
So what about the mechanism of being truly transparent with the data?
So there are some areas that's really important. So I don't know if people know, so the interesting thing is that as well as this whole idea of open access, so everything that is now published in Europe very shortly is going to be available to everybody in the public. Everybody gets to see all the science that's publicly funded, which is, I think, a great idea. On the other hand, there's also something called open data, which means that all the data that's in the paper has to be also accessible to everybody. My own view is, well, it was a nice idea. It's very expensive to do, and at the moment it's a complete waste of time and money. And so the idea was that if I've done an experiment, I've got a lot of money in my lab, I've done these great experiments, but I don't have enough time to analyze it all. If I allow everybody to look at the data, then they should be able to find a lot more. So, all these scientists in India who aren't funded but very smart should be able to look at it and find all sorts of new things out. And it would be great, but I don't know a single example. And we've been doing this for 5 years now.
I can give you 15.
It's possible that there's a culture that has to emerge, but I think actually if we want to do that, we have to train people in doing that. You can't say it's just data. And actually, data doesn't mean anything without the story. That's my real point about it. So you have to somehow combine these together. But it's a really interesting series of questions as well.
Did we have a question up here? So we'll go here and then we'll come to you. Yep. So just up here in the corner. Thank you.
We have to wait for a microphone because it's high technology these days.
Other than creative anarchy that you suggested, how else do you think we can reintroduce biodiversity into the scientific ecosystem?
It comes back to the question here. You can do some interventions. So one of them I was suggesting was some other metrics. If you put in other metrics, then it starts to help this problem of who should I hire, how do I rate people, this sort of thing. So I think that's probably something that I would encourage very strongly and probably would lead to a lot more progress. So, I mean, really, it's only 15 years since somebody came up with the H factor and it just sort of took over like a virus in the system. People have suggested other things, but they haven't stuck. I think people know that there are problems here now. Particularly, it's a problem for encouraging the diversity of scientists themselves, because you only get certain sorts of scientists who might prosper into this sort of economy, but you want diversity. So you want, places where people can hide away and do things without the full glare of that. So I think that's the thing that I would say at the moment, because we are a very metric-driven, we need some way to measure each other. I don't know, do you have any ideas?
Moving that H factor?
I mean, so there's a great declaration of people saying, H factor's terrible, don't use it. But they don't tell me how to sort 500 applications. So how do I decide if somebody is doing good science and I should put resources there? So as I said before, it's terribly difficult to decide with £100 million, where should you put that money? Because you have far more really, really good scientists who are doing really good things, who far more money needed. So, and it's always going to be a political decision. Scientists hate politics. Often they say, I went into science to avoid politics. But of course, deciding where resources go is politics. That's exactly right. And we have to make the best decisions that we can. So you just want to use a range of factors. So if you do have to use H factor in my view, but you have to use it with a range of other tools as well. Yeah, you can't just ban it.
Thank you. Just the gentleman on the end here.
My question is about the political and economic structures we live in and how they affect what you might call good science. If you look at the history of the space program, for example, you had the capitalist West with nukes pointed at the communist East, and somehow this morphed into a beautiful collaborative space program between the two kind of sets. Have you done any research on which political economic structure leads to more good science?
And the short answer is no, because it's this enormous topic. So if we think about the science of the period, that there is, when I was a young student, there were, after 91, there was an enormous number of Russian scientists or Eastern European scientists who were coming to the West. And also the literature opened up from their side as well. So one of the things that I would do is I'd mine their literature. I've had a Russian speaker, so I could try and think about ways to go forward before anybody else saw those ideas. But on the other hand, if you talk to Russian, their general idea was, yes, it was done before. Go and look at the 1960 paper in the ATP. And so there was a lot of really, really good science that had been done that was out of contact with Western science. So it's clear that I think science can prosper in different models. In that one, I would say it's because a lot of very smart people who might have gone into other areas that were more overtly political actually went into science because it had a freedom about it. As I said, freedom is really essential for it. And you really can't fund science without also giving it some freedom. So even in a repressive regime, if it wants to really do science, it's going to have some freedom associated with that as well. So you can say it's sort of, regime change happens subtly through science, which is why the Americans wanted to do it. On the other hand, I think the problem is this thing about diversity. If we all do it the same way, then we're going to just miss whole areas of science. For instance, trying to understand how biological systems work, the problem is that there's so many things going on at once. We can look in all the details, but we miss something. We're clearly missing something. We try and map enormous numbers of things going on, but we need to have a whole diversity of ways of thinking about science to help with problems like that. They're not just amenable to ways that we've developed in the traditional science areas. So I would say, again, trying to encourage different ways of it happening rather than a particular regime. Yeah. So there are some interesting things about, if you look at the split between the amount of science being done in, say, industry and the amount of science being done in academic institutions. Very, very big differences in different countries. Or also the efficiency of the science funding. One of the most amazing things is if you try and come up with some measure of if you invest £1 in science, how much do you get out? Britain is one of the most, it's actually the most efficient science funding country in the world. There are countries that spend 5 times more on getting the same amount of sort of science out, sort of however you measure it, really. And so you can see two views there, that in Britain we're really good at underfunding our science system, right? Or if you're Treasury, you say, why would we change anything? It's perfect. And it's something about if you get too much money, maybe you don't look in unforeseen directions. You just buy the latest bit of kit and you do it that way. You don't think about, well, maybe we could do it this way, which is actually a traditional British strength. The string and sealing wax is not that far from it. So that my UK colleagues might not like it. I might say, it's not obvious that you should completely change the system because you don't know where you'll go when you do that. Yeah.
Any other questions from this bottom section before I go up the top? Yep, at the front row here.
You mentioned that the value the journal provides to you is helping the best papers float to the top of the search results. That value is really provided by the peer reviewers who do that service for the journal for free. The authors provide the papers to the journal for free. The journal collects either open access fees from the author or they collect fees from the reader of the paper. So it's not actually obvious what value the journal provides. Is there a way forward without?
Well, the funny thing is, it is obvious what it provides, but you'll hate it, and it's brand. And it's just the same as the shops, right? I mean, I can buy the same item that's come from the same locations in China in just down around the corner here, and it will cost me 10 times more than if I buy it in a different location. And yet, a whole lot of people go and buy it over there because there's something about that brand. But the brand is still doing something for me. I mean, I completely agree with you. Science publishing is known for, milking the system, if you like. But it is actually still providing a service that is useful. It's not that those science publishers should do it, but somebody should do it. And it's very difficult to move the system from where it is. So I would argue this is a tax, but it's providing a useful service. And sometimes we could try and go to another system, but we'd probably find it was worse in the long run. We'd actually be paying more money than this system, and that's not talked about very much.
So hundreds of years ago, when this academic publishing tradition was established, they got it exactly right. Is that your assertion?
No, it isn't. It's just that it's easy to say that the people who are making all the money out of the system are definitely, it's bad. And it's frustrating. I completely agree with that. But it's not completely obvious to me. Well, I just need those journals there. And I need some way of having a pecking order. So what does annoy me about this thing I was talking about publishing is that every journal has its view about what paper should look like. So whenever your paper is rejected, you have to reformat it and read all the figures and put it into another journal. So that, completely unnecessary in some ways, that they say, no, our way is best for this sort of science. And it's hard to really argue with that. So it's possible, there is another way I could see it would happen, actually, because the competition is so strong. So what we could all do is when we submit our papers, we submit them into a pool, and now the journals can bid for your paper, right? So it turns the thing around. So they would bid, and then you would be able to say which bidder got it, right, to be able to work with. And it would just turn that around. It would still function the same way. I don't know that the money would change, but it is a different way of doing the system, and it makes it clear that they're just competing extremely strong with each other. And the editors on the journals are competing with each other. So many journals they're trying to increase their impact factor. They'll do it any way they can. So they have a number of editors trying to get the best papers, and they'll rate them at the end of the year. And the ones who aren't getting the best papers, they'll be out. So it's a very, very competitive system. So those editors are not talking to each other. There's no collaboration in that at all. It's terrible. I mean, my view is that it's a terrible way of trying to support people and also support science. I still feel that this esteemed tree is incredibly useful, and just losing it would be a complete disaster. So somehow, and it's not obvious that just replacing it, so that the peer review system still works. That's the thing about it. This use of reviewers who are able to comment very seriously on a paper without any of that being made completely public is extremely useful. There's a lot of, you can get into problems, but actually it always improves the quality of the paper. Always improves the quality of the paper. And so that's what I want to see. So unless you have a really good idea which answers all these, then I'm going to stick with it. I'll pay my tax, just like I like doing anyway.
Are there any more questions down here? Yep, gentleman there.
Yeah, it's interesting, but you talked about paradigm once. I think you mentioned paradigm. And I'm still concerned about how you would assess, it doesn't matter what science it happens to be. I'm a social scientist, so I'm one of the fewer of the people that you talk about. How you would assess something or somebody, some new system of knowledge, which is not yet part of the peer review section and the normal science. And from what you're saying, and I agree with you, that it'll come up to most peer reviewers and they will say, well, I don't mind what kind of science it is really. They'll say, well, this is rubbish, you know.
Yep.
And at some point, clearly, as with nanotechnology and so on, there had to be a breakthrough when suddenly something became acceptable.
So this idea of
so how does it happen?
Yeah, so there's an idea of paradigm change, and there are some areas where it does happen, and social scientists have actually studied that part of science really well. So the really classic example is this one of gravitational wave detection, which is really thought to be kooky science by most scientists for a long time. There's money put into it, but you know it's never going to be detected. The signals that you're going to get incredibly small. So what's interesting in that area was how do new ideas come about there, and it's more of a social construct. If somebody's very charismatic in that field, they can take a whole field with them into a particular direction. My view is that that's a very, very small amount of science. So all the science I've ever been involved in is not like that at all. Instead, the new idea, it will succeed. It depends on its utility. It will always find a place to be published. It may not make the very highest journal to start with. It'll go down. But if it works, if it's good science, it will get picked up and taken somewhere because people find it. So there's enough ways to find what's going on. Normally what happens is because science is so interconnected, if somebody's working on it on this part of the world there, somebody else is. Actually, there's normally about 5 or 6 people. So rarely does a discovery now come out of the blue, which is also what the terrifying thing is. So even if you're working in a backwater, you can be sure that there are 10 other groups doing that. And so all I can tell my students is, you know, well, yeah, but that's also a very bad way to work as well. So it's about trying to find something. My own strategy is one where you do something in an area, but you combine it with another area. So now it becomes highly unlikely that somebody else is doing both of those. And then if you combine it with a third area, so it's a bit kooky, a bit strange, but it's really interesting, but very, very unlikely somebody's doing that. And that's how I protect young scientists who are coming up, because it's very unlikely somebody's going to do exactly the same thing. So that's my argument about trying to broaden things out, but I can do that now. Got funds to do it. But it is a problem. You know, how do you get an airing of ideas? I just think it's very, very rare that a really dramatic idea that's right will not find airtime somewhere. Maybe the reverse is true. There are bad ideas that are overhyped and publicized that do get airtime that don't deserve to get airtime. But that's also a penalty that we have in the system. You have to, that's fine. It'll evolve. It'll fall off the tree. And then the real stuff will stay because it's robust.
Any other questions? Oh, I mean, does anyone have? Yeah, go on then.
So you seem to have documented how the system works really well. Where next?
Yeah, so that final chapter was worrying because I had this sense that it's possible somebody could ask me to then enact all of these ideas and see what works. So partly it's what I really do in Cambridge. Every country has elite institutions. We need this range of sort of young, dynamic ones. I was in Southampton for some time. That's very much like the west coast of the States, where I was for also some time, very dynamic, you know, just do it. When you go to an elite institution, you say, let's just do this. They go, yeah, it was tried 50 years ago and it didn't work then. And, you know, but actually, so they have to be dynamic. And so that's sort of my role, I feel, in Cambridge, is trying to encourage some of these different things. So, but on a national scale, I think it's also important to be trying experiments. The good thing about the UK is because it has quite a good structure of funding science, has a lot of good people involved in doing it, and it also does try strange experiments. Which, you know, is open to doing that. I think that's very good. There's a fantastic thing going on at the moment, I don't know if people know, which is this thing called a Global Challenges Research Fund, GCRF. And the government took a huge chunk of the aid budget, which nobody was very convinced was doing something very beneficial, and said, let's try and put that into science funding, where it still has to be going to a developing country, so it has to really benefit the developing country, otherwise it doesn't count as aid. But the idea is to get scientists to work with other people in those countries to actually evolve something useful. I think it's a great experimental idea. It's, you know, at least trying something different, and it's connecting. All sorts of unforeseen things come out of it. So that's what I would say is you know, the thing that's good. I think that's the best thing about countries, is if they can try experiments, that's a very good thing. And actually, Britain is pretty good for being able to do that. And so I think that's one of the reasons we do quite well in science. Don't know if that's an answer to where's next. I'm trying not to take any responsibility.
You have the as-is situation. What's your vision for where this goes? So, if we were standing here in 5 years' time, what progress would you like to have seen? What difference would you like to see in
So there's
the
quite a bit
system
of work by the Royal Society and the research councils at the moment trying to look at science, the ways of doing science. And I think there are some interventions that may come out through that. I think there's an appetite for realizing this whole system. I don't think most scientists do, but I think people know the problems. So there's an appetite for trying to do some intervention. So I think some of those things will happen. I think there has to be some top-down interventions as well. And I think that's on the area of metrics. I think there's going to be some work. Some of that will be commissioned. So I think there'll be a range of different things. And so my guess is over the next 10 or 15 years, there'll be sort of experiments in different countries trying different things. The difficulty is, like I said, in Britain, I think one of the things that we do very well is that we actually do collaborative science very well, because we haven't set up this it's not quite as competitive here. So nanoscience is actually doing really well here. It'd be hard to do what I'm doing in the US, because there'd always be this question, well, I'm collaborating with somebody else, so is it my work or is it their work? Yeah, and we don't ask that question here. It's just really good science and technology. It's just what we should be doing. Just China also, there's that sense of, is it mine or is it yours? We have to divide it, and it's, So I think, we have some opportunities to see how different countries play this. But at the same time, if the UK is being very nice, we're very collaborative, but everybody else does everything first, that's going to be hard to make changes. Yeah, that's probably. I think the other thing is I'm actually trying to actively encourage some work in this area of AI and big data on science, because it feels to me there's lots of work on things that you can monetize and the data from our phones and everything like that. But actually, all it is to push advertising to you. So in the science sphere, that's not what would happen. It's actually be a much more efficient way of doing science, and it would identify some more of these other areas and would stop us concentrating just on bandwagons. So I really think we should do that, and it should be like a big challenge. It's a difficult project, but it actually is one that's tenable now. So I'm trying to raise the incentive to do that.
Okay, so we have time for one more question if there is one. Yeah, well, there you go, gentleman over there. It's the last question.
Apologies if you gave this answer already, but you asked us at the beginning to guess how many scientists there are, and I don't think you actually told us the answer.
No. You see, that's why I'm very naive. So when I wrote my book, I told everybody everything. And now I always keep at least one number back. So that's the number I'm going to keep back. Good question. No, we know, actually, it's the one number that we know probably better than any other number, I would say.
Sorry, was there a question on this side? No. Excellent. Okay, well, thank you very much, everyone, for coming for this evening's talk. If you do want a copy of Jeremy's book, we are selling them just outside in the room outside the theatre. That was a very clear and concise talk. Jeremy, I took a lot away from that, and I want to go find my H number now just to see what it's like. But a round of applause, please, for Jeremy.